Welcome to lesson number 3. We're going to be looking at multiplication of two binomials. I'm going to do class example A, and then I'm going to do class example 1D first. So we want to complete these algebra tiles by multiplying and then determining the binomial products. Okay, so first of all, I have an x and an x, and these are positive. So x times x would result in x squared. And then I have this x times my 1's, which is 1x, and then this one here is another x. And then I have this x times these ones, which is going to be an x there, an x here, as well as another x here. But then I have this set of 1's times this set of 1's, so there's 3 1's times 2 1's, which is going to be 6. So 1, 2, 3, 4, 5, 6. And remember, these are all positive, so we should shade these in. This orange means they're positive. Now what we're left with here is 1x squared, so x squared. And then we have 1, 2, 3, 4, 5 plus 5x. And then we have 6 1's plus 6. Now, if we follow this same process, and down here we have a -1, let's see what the difference is. So, actually for this one, it's a little bit trickier, see, because we have to now fill in the two missing binomials. But I have on this side I have x plus 2, or it looks like whatever, x plus 2, and multiplied by 2x minus 1. Now we can multiply an x times an x, which is positive, results in an x squared. And I have another x squared on this side when I go this x times this x. And then I have a -1 times a positive x, which results in a negative x. And then I have this x times this set of 1's, which is going to be x, and this one times this one, which would also be x. And then I would have these ones times these ones as well. And then my 1's are left over, which would be -1. And so if I, shade these in, shade in my positive values, these are my positive values that are left over. And I would have positive 2x squared. And I have 1, 2, 3, 4x minus 1, which would be 3x positive, and then -2. So another way for solving those previous examples is if we set up our tile diagram like this when we have into 4 monomial products here. And so if I have, x plus 3 times x plus 2, then I would have x plus 3 on the top, x plus 2 on the side here, and then I would just multiply each of them like so. And then I would combine my like terms. So x squared plus 2x and 3x is 5x plus 6. So we're going to do that for these examples down here. We'll set up a quadrant system like so. And on top, we're going to have 5x minus 6, and then we have 2x positive 1 on the bottom. And then I just multiply like so. So 2x times 5x gives me 10x squared. 2x times -6 gives me -12x. 5x times 1 gives me positive 5x, and -6 times 1 gives me -6. If I combine these like terms, I would get 10x squared. -12x and 5x would result in -7x, and then -6 is what I would have left over. Now let's look at an example where I have two variables, and so we would take the same approach with these two, but I want to show you this one. So again, let's set up our grid as we set it up earlier. So I have 3p and 2q, and then I would have p and 9q. So 3p times p would result in 3p squared. 2q times p would result in 2pq's. And then 3p times 9q would end up in 27pq. And 2 times 9 would be 18q squared. That means that this results in 3p squared combined by like terms, positive 29pq plus 18q squared. We have our long multiplication method as well. So looking at the long multiplication method, so for example, if I had the product 32 times 34, we can set this up without a if we want to do this without a calculator, by long multiplication. So we have 30 plus our 2 and our 30 plus our 4, and we would multiply numbers that are just easier to work with. So 3 times 3 plus 2 zeros would be 900, 3 times 4 plus a 0 would be 120, and we would take that approach and then add up all of our components. So this is called an area diagram. Long multiplication, you would set it up like so. Area diagram, we would set up like this. So use an area diagram and no calculator to determine the following products. So 43 times 51 and I'll just do this first one for you. So I would set this up as 40 plus 3 and 50 plus 1. Now when I multiply 40 times 50, I would actually multiply 4 times 5, which is 20, but I have two zeros, one 0 from the 40 I need to add, and another 0 from the 50 I need to add. That would give me 2,000. And then I would go 5 times 3 is 15, plus another 0 is 150. 40 times 1 is 40, and 3 times 1 is 3. Now, just like we were doing earlier, we add up all our components, and so I'd have 2,000 plus 150 plus 40 plus 3. Now 150 plus 40 is 190 plus 3 is 193 plus 2,000 is equal to 2,193. And that's the exact same thing we were doing with our area diagrams above here as well. Now that's not the only way to multiply binomials. We can also multiply binomials using the distributive properties or the distributive method. Now, when we're using the distributive method, we use a process that I'll explain in this next section here. But I gotta distribute my my values to both sides of my equations, like so. And so you use the distributive property to determine the following products. So x plus 3 times x plus 2. Now what I'm going to be doing is multiplying both sides of my equation by one of my values here. So x plus 3 times x plus 2. I'm going to distribute my x to multiply both of these and my 3 to multiply both of these as well. So my first step is just working with this x, and that's going to be x times this whole side of my equation, which is x plus 2, and I'm going to add my 3 to this whole side of the equation, which is also x plus 2. Now when I do that, I get x squared plus 2x, and then I have to add, oh sorry, my 3 has gone missing, there it is. I have to add this 3 times x, which would be 3x plus 6. And when I combine those, I get x squared plus 2x plus 6x, which is 5x plus 6. So this is using the distributive property. And I'll also do this example down here. So 9a squared, the way we would set this up is 9a squared times 5a cubed plus 6. And then I'd have minus 1 times 5a cubed plus 6. So 9a squared times 5a cubed would result in 45a to the power of 5. And then I would have 54a squared minus 5a cubed from that 1, negative 6. And in descending order, we would have 4a to the power of 5 minus 5a cubed plus 54a squared minus 6. Now, there is one more method for multiplying binomials. Now, the last method for multiplying binomials is known as the FOIL method. Now, FOIL is still using the distributive property. What FOIL stands for, like this, is an acronym. So the first term in each bracket, followed by the outside terms, followed by the inside terms, and then the L is the last term in each bracket. And so I'll show you how to use FOIL. Now, x plus 6 times x plus 4, we're going to multiply the first term in each bracket. The first term in these brackets is x times x. X times x will result, so x times x is going to result in x squared. Then we multiply the outside terms in each brackets. All right, so the outside term, this is an outside term, and this is an outside term. So x times 4 would be plus 4x. Now we do the inside terms of the brackets. So these are the inside terms here. That would be 6x. And then the last term would be 24. 6 times 4 plus 24. Then we combine our like terms, and we would get x squared plus 10x plus 24. Next, I have 6a squared minus 5b squared. Now, when I square something, what this means is I have 6a minus 5b times itself, 6a minus 5b. Right? That exponent means we're multiplying it by itself, like so. But now we can FOIL this as well. So 6 times 6 is 36. A times a is a squared. 6a times 5b would be negative 30ab. 5b times 6a would be again negative 30ab. And then negative 5b and negative 5b would be positive 25b squared. Combining these like terms, we would result in 36a squared, negative 60ab, positive 25b squared.